Excel has a whole bunch of functions that allow us to deal with dates, and I'll run through some of the most popular ones here. I have real dates in column A. Let's say that we need to find a date that's 30 days past the date in column A. Well, the great thing about dates, remember that Microsoft stores dates as the number of days since January 1st, 1900. Every day is equal to 1. So if we need to go 30 days from a date, it's very simple. The equal sign, point to A2 plus 30. Believe it or not, that's the right answer. It's just not formatted correctly. This is the frustrating things with dates. Lots of times you'll get exactly the right formula and exactly the right answer, just the wrong format. Go to the home ribbon, and from the number drop-down, change to short date. Because there's 31 days in January, 30 days after the 22nd is February 21st. We'll double-click the fill handle to copy that down. Another function that's useful in dates is the date function. In the date function, you have to specify a year, a month, and a day. If we want to figure out the date that the month started, we can use the date function, equal date. Excel wants the year, and so I need to copy the year from A2. I'm going to use another function here called the year function. So I ask for the year of A2, and now Excel wants to know what month. Again, I'll use the month of A2. And now Excel wants to know what day. Simple enough, it's the 1st. Closing parenthesis, Control Enter. Again, we have the right answer and the wrong format. Now at this point, I realize I'm going to be entering dates all across this worksheet. Let's just format the whole worksheet as dates. To select all cells in the worksheet, we click this blue box to the left and above cell A1. That selects all of our cells. Now in the number drop-down, choose short date. Everything else that we enter in this worksheet will now be evaluated as a date. Choose cell C2, double-click the fill handle to copy the formula down. Now if we would like to convert the date in A2 to a month, there's a couple of ways to do that. The first way, and I'll have to admit it's sort of cheating, is just to enter a formula that says equal A2 and then go to Format Cells. The fast way to get to Format Cells is to click the More icon at the bottom of the number group. Format this cell to look like a month. March 01 is the example. Click OK, and when I copy the formula down, it will now convert all of my dates into something that looks like a month. I have to warn you though, if you're later using subtotals or any kinds of date calculations, Excel is truly storing not June 07, it's storing June 16, 2007. The proper thing to do is to use the date function again. This is basically the exact same formula that we typed in C2, so we need the year of A2, the month of A2, the number 1. Format that result as a month. Control 1 to access Format Cells, scroll down, and use March-01. Double-click the fill handle to copy. The next one is a little bit harder than the beginning of the month. We have to figure out the end of the month. I remember a great argument that broke out one day about the best way to do this. People started saying, well, we have to check and see what month it is. If it's a month that has 31 days, then we'll use 31. If it's a month that has 30 days, we use 30. And then if it's February, we have to figure out if it's a leap year or not. And 1900 is not a leap year. And someone walked up and said, wait, you guys are doing it completely wrong. Use the date function. Equal date. We'll take the year of A2, the month of A2. But I'm not going to type the comma yet. I'm going to add 1. So I'm actually moving ahead to the next month. And then the 1st of the next month. In this particular case, it will give me February 1st, 2008. From February 1st, it's just a matter of subtracting 1 day, so I'll put -1, to move back to the last of the month. Double-click the fill handle, and it works perfectly, whether it's a leap year or not. You'll notice in row 11, we have February 4th, 2007. It knows that that February has 28 days. If we would change that to be February 4th, 2008, it would know that that February had 29 days. Now, I hear what you're saying. How does it work in December? Take a look at December. This function is asking Excel to take the year 2007, the 13th month, the first day, and subtract 1 from it. Well, amazingly, the date function is perfect at handling that. You can do something crazy, like ask for the year 2007, the 43rd month of that year, and the 300th day, and Excel will understand what you're talking about. Excel started from the year 2007, added 43 months, and then added 300 days and calculated the right date. The date function is fantastic. Now, in old versions of Excel, there was something called the Analysis Tool Pack. The Analysis Tool Pack has 89 functions, and the problem was that some computers had the Analysis Tool Pack turned on, and other computers had the Analysis Tool Pack turned off. A lot of companies said, hey, you are not allowed to use any of the 89 functions in the Analysis Tool Pack because we don't want problems as we go from computer to computer. In Excel 2007 now, they've enabled all 89 of those, and they're part of the core Excel. Thus, you're able to start using the EO month. It stands for end of month. You have to specify a start date. So we want to start from January 22nd. And we can even specify the end of the month several months away. But in this case, I don't want to move any months away, so comma 0. EO month is a much faster way of doing the formula we did in column F. Of course, the gotcha is you have to make sure that you're not sharing this workbook with anyone who has an old version of Excel and has not installed the Analysis Tool Pack. Excel does a great job of giving us many different functions for handling dates. There's a couple of great new date functions in the Analysis Tool Pack. Let's go on to the next worksheet to take a look at those. Well, I've kind of reached the end of where I can see the next worksheet tab. Good time to talk about the 4 controls in the bottom left-hand corner. These controls let us scroll through one worksheet at a time so we can bring more worksheets into view. I'm sure you knew about these controls, but I bet you didn't know that you can right-click and see a list of all the sheets. Great tip. Let's go on to the Census tab. This example is a great example for anyone in human resources where you need to keep track of your new employees. We have employees in column A, their hire date in column B, and a date in column C that shows off today. You'll notice out to the right-hand side I've typed in a list of the company holidays that are relevant during this period. I need to figure out how many work days the person has been on staff. Both of these functions are brand new in the core Excel, but they've been in the Analysis Tool Pack in previous versions. So the first function we're going to use is called the net workdays function. This finds the number of workdays between two dates. We have to specify the start date, that's in cell B2, and then the ending date, that's in C2, and then optionally a range that contains a list of holidays. Excel will not include these holidays as workdays. I want that reference to be absolute, so I'll hit the F4 key. Closing parentheses, Control-Enter to accept the formula, and we'll see that Gloria's been here for 17 days. As I double-click the fill handle, we'll very quickly see how many days everyone has been here. Now let's say that this company has a 60-day probation period. Go to cell E2. This time we want to use the new function workday. We'll type equal workday, specify the starting date. Say that the probation is 60 days, so we want to see 60 days after the start date, factoring in these holidays. Again, I'll hit F4 to make that be absolute. Closing parentheses, Control-Enter. That's the right answer. Wrong format. Remember on the last sheet, I changed the sheet to always show dates. I need to change this cell. I'll go up to the number tab and choose short date. Perfect. They were brought in on December 16th, 30 work days, ignoring holidays, is March 12th. Double-click the fill handle, and we'll have an end date for everyone's probationary period. Those are both great new additions to the date functionality of Excel. Hey, let's move on to the timesheet application. Now, if Excel stores dates as numbers, Excel stores times as fractional periods of a day. Here's an example. 24 hours is the number 1. Noon, then, is the number 0.5. 6 a.m. is the number 0.25. 6 p.m. is the number 0.75. Let me show you how this works. I'll come to a cell, I'll type in 0.25 and Control-Enter, and now format that cell as a time. Sure enough, Excel converts that to 6 a.m. because 6 a.m. is 25% of a day. Well, this works out pretty well and means that we're able to do calculations from an end time to a start time just by doing a simple subtraction. The formula here is B3 minus A3. The format is a little strange. Let's go into Format Cells, Control-1, and take a look to see if there's other time formats that would be more appropriate. Instead of saying 8:30 a.m., if I use this format, the 1330 format, it will show me 8:30. That means the person worked 8.5 hours on this day. I'll copy this formula down by dragging the fill handle, and you can see that they worked 4 hours on Tuesday, 9.5 hours on Wednesday, 8.5 hours on Thursday and Friday. Click in the total cell in C8 and use the AutoSum button. I hope your payroll director is not using Excel to track your timesheets. If so, you're only going to get paid 15 hours for this work week that was almost 40. What's going on? How could Excel have this problem? Remember that Excel stores times as a fraction of the number 1. In this particular case, the person has worked more than 24 hours, like most of us would, and has in fact worked 39 hours this week. Excel doesn't want to show us the day portion because it really thinks that we have probably formatted this cell to show dates and times. If I go to the date category, scroll down, and choose date and time, you'll see that Excel has moved forward and it now has 1 day and enough hours to get us to 3 p.m. That's 15 hours. The solution to this is very obscure. If you look through the time formats, there's an option called 37:30:55. This is the format that tells Excel to show hours in excess of 24. You specifically have to go into Format Cells and choose that obscure time function in order to make your timesheets work. Let's move on. We'll go to the next worksheet. Now here I want to do a quick review about one of Excel's operators that you might not be familiar with. This is the exponents. If you need to raise a number to a power, you have to use the exponent symbol, which is the caret. That's the funny little pointy hat that's the shift 6. So for example, if I enter equal 3 caret 2, Excel will raise 3 to the second power. 3 times 3 is 9. If I edit that and use equal 3 caret 3, 3 to the third power, that's 3 times 3 times 3, is 27. Now let's say that we have a number that's squared. For example, 5 to the second power is 25. To figure out the square root of that number, Excel gives us a function, the square root function, equal SQRT. The square root of 25 is 5. Simple enough. But it's possible to raise a number to a power larger than 2, equal 3 raised to the third power. How do we take the cube root of a number? There is no function beyond square root. There's no function for a cube root or anything like that. The trick is going to require you to go back and remember high school math. Turns out that taking the cube root of a number, that's the third root of a number, is the same as raising the number to 1/3. Watch how this works. Equal 27, the exponent symbol, and then in parentheses, 1 divided by 3, will take the cube root of 27. This works for fourth roots, fifth roots, and so on. Now, it's rare that you're going to have to work with this unless you're the person responsible for figuring out how fast your company has grown. Over on the left side of the worksheet, we have sales figures for year 1 through year 5, and we want to figure out the compounded growth rate from year 1 to year 5. Well, the total growth rate, the formula here in D5, is simple enough. We take the last year divided by the first year and subtract 1 to see that we've grown 537% over the 4 years. But that's a completely different calculation than the compounded growth rate. Compounded growth rate requires you to take a root. In this particular case, from year 1 to year 2 is 1, year 2 to year 3, that's 2 years, year 3 to year 4 is 3 years, year 4 to year 5 is 4 years, so we need to take the fourth root. Take a look at this formula. We take the last year divided by the first year, and then raise to the 1/4 power, and then subtract 1, or 100%. That'll show us the compounded annual growth rate is 59%. It's not often that I have to pull out the exponent symbol in order to figure out complex roots, but this growth rate is one that comes up again and again and again. Let's move on. VLOOKUP is one of the most used functions in Excel. In Access, we join tables all the time. Sometimes we need to take values from a lookup table and bring them into our data set. On the left-hand side, I have invoice, SKU, and quantity. This came from our IT department. It's exactly what I asked for, but not what I needed. I really need description in that data on the left. Well, luckily, somewhere on my computer, I have a table that you see in column I and J that converts SKU to description. It's a simple process to use VLOOKUP, which stands for vertical lookup, to find the corresponding value from the table on the right and bring it back to the table on the left. Let's build one. Choose cell D2 and type equal VLOOKUP. First thing we have to specify is what SKU we want to try and find, so we'll click cell B2. Click the comma, and now Excel is asking for a table array. The important thing about this table array is the SKU, the value we're looking up, must be in the leftmost column of the table. I'll click in cell I2, hold down the Shift key while I use End, Down, and then Right to select my table array. Very important that I hit the F4 key here. As I copy this formula down, I always want to make sure that I'm pointing at rows 2 to 29. Type the comma. Next, Excel wants to know which column we want, and this is the column and table array. If we ask for 1, we would just get the SKU again. If we ask for 2, we'll get the description from the second column of the table. Finally, we have to put either true or false. It's nice in Excel 2007 that we have the autocomplete here guiding us to remind us that false means an exact match. Almost all the time, you're going to use false, especially here. If we had an SKU that was similar to one of our SKUs, that doesn't mean it's the same thing, and you wouldn't want to bring that description over inappropriately. Control-Enter to select the formula. Worked perfectly. I'll double-click to copy down, and most of the time, it worked. However, in row 6, there's one value that's returning an NA. That's strange. I wonder what's going on. Maybe BG33-9 is a brand new product, or maybe someone miskeyed the product when they were entering the invoice. I can see on the right-hand side that BG33-8 is there. I could probably make some calls and see if that's really what the customer bought. If I change to the correct SKU, the VLOOKUP works. VLOOKUP is a very, very powerful function. At my last day job, whenever I was a manager, one of my job requirements was I didn't care whether you had a college degree, but you had to be able to use VLOOKUPs in your sleep. Let's move on to another example, and I'll show you how VLOOKUP can go wrong. Select the VLOOKUP 2 worksheet. Now here I want to enter the exact same VLOOKUP formula. Equal VLOOKUP, B2, specify my table, hit the F4 key, ask for the second column, and type false. This time, I don't get the right result. I'll copy the formula down, and I don't get the result anywhere. So I start to look, and I can see in B3 we have BG33-3, and in I2 I can see we have BG33-3. I can match these up. What's Excel's problem? How come it can't see the match? While those values look the same, one of them is probably different. Let's do some investigation. I'm going to click on cell B3 and hit the F2 key and watch the insertion point. The flashing insertion point shows that there's several spaces after BG33-3. Let's go look in our lookup table. Choose cell I2 and hit F2, and here we see the flashing insertion point is immediately after the 3. Somehow, one of these tables came from a different source, where they left the trailing spaces. Now this is the easy one to fix. If the problem is in column B, we just need to go back to our formula, edit the formula using F2, and use a function called trim. The trim function will trim leading and trailing spaces off of a text value. Works perfectly. We'll copy it down. Now there's a few products in there, the BG33-9 and the CR50-4, which were either keyed wrong or are brand new. You'll see in CR50-4, the problem there is that there's an internal space, whereas on the right-hand side, there is no space. Trim is great at taking several internal spaces and turning it into one space. So for example, if I had the letter A, space, 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 the letter B, trim would change that into A space B. It will not get rid of the internal spaces. I probably have a job here to go through and fix these, or I could use edit replace on column B to take the spaces out. For the most part though, the trim function worked perfectly. Let's go on to the next worksheet and see what happens if the problem is reversed. I'm going to enter the VLOOKUP formula again. B2, specify my table array, making sure to hit F4, ask for the second column and false. This time none of them work, and when I look in cell B2, it appears to be fine. There's no trailing spaces. Let's look in cell I2, hit F2, and this time the trailing spaces are in our lookup table. Well, I'm just going to have to stop and fix the problem. I'll come to cell H2 and enter a formula of equal trim of I2. Copy that formula down. It's interesting here, the double-click the fill handle trick works provided there's data to the left, or in this case, data to the right. I've now removed the trailing spaces. I need to change these formulas to static values. I'll use Control-C to copy, go right, and use paste values. There we go. Instantly, most of my VLOOKUPs work. I still have the problem with BG33-9, and we have to figure out if that was miskeyed or new, and the CR50-4, now on the right-hand side, has an internal space. But 90% of them worked. VLOOKUP, very, very powerful. It definitely should be something in your toolkit. It's great for bringing descriptions when the IT department just gave you part numbers or rep numbers or account numbers or whatever. I have one last example that's sort of in the VLOOKUP genre, But it turns out you can't use VLOOKUP to solve it. Let's go on to index match. Here I have a simple form where someone chooses an SKU from cell C2, and then the VLOOKUP in C4 does its job. It goes out to the table in L and M and finds the description for me. But now I need to find the price. Well, this is tough because the price is located to the left of the SKU in my lookup table. Excel veterans would say, hey, this is easy. Just take column K and move it over to column N, and then you can build a lookup and ask for the third column. It would be great if Microsoft gave us the option to say we wanted the -1 column. In other words, go to the left of the key. But they don't do that. It's interesting, the solution to this problem involves two functions which appear to be completely useless. Let me describe the functions to you. The first function is the match function. The match function works exactly like VLOOKUP. It says, go take that value in C2 and look through the SKUs in L2 to L29. The false means we want an exact match. When it finds the match, it will tell us what row number in the range it's found. So in this case, ER46-7 is on row 18 in my worksheet, but that's row 17 of the lookup range. When I first read about this, I said, how could this possibly be useful? I've never had a manager call me up and say, hey, what row number is that customer on? It just didn't seem like anything I would ever use. Let's talk about the other function, the index function. This one seems completely useless as well. In the index function, we specify a range, such as K2 to K29. We then have to tell Excel which row in the range and which column in the range we'd like to return. I thought about that and I said, okay, if I wrote equal index K2 to K29, I want the fifth row and the first column, why would I ever do that? It would be so much simpler just to say equal K6. It made no sense to me how either of these functions would ever work. But it turns out that if you put them together, they solve this problem of the VLOOKUP left. The inside function, the match function, goes and finds what row number in the range our product is found on. And then we take that number and put it as the row number argument in the index function. So index says, look through the prices in K2 to K29. Which row number do we want? We want the row that matches the SKU in C2. Pretty slick. Now again, I can hear the Excel veterans saying, hey, it just would have been simpler to take the price in column K and move it over to N. I agree with you, but in case there's ever a situation where you can't move the column, using index and match is a great solution. Let's move on. Another function that's very, very hard to understand is the offset function. But this function is incredibly powerful. Let's take a look at Excel's help. I'll type equal offset, type the opening parentheses, and then type Control A to open up the function arguments dialog box. It says that offset returns a reference to a range that's a given number of rows and columns from a given reference. In other words, you have to specify a starting point and then tell Excel to move down a certain number of rows, write a certain number of columns, and then it specifies how many rows and how many columns to return. That's pretty arcane stuff, isn't it? But here's where it really comes in handy. On my worksheet, I have a list of sales. There's months going down the side and sales in column B. Every month, I open the worksheet, I add a new month, and I add a new sales figure. I want to find out the sum of the last 12 months. And I don't want to have to adjust that formula month after month after month. We're going to build this in a few steps. The first step is to figure out how many sales numbers we have at the current time. Formula for how many. Now, I don't want to build a count function that would count from C2 to C18. I want that to expand every month. I'll come here and choose equal count and just put in B:B. Tells me that we have 17 values. Let's check and see if that worked. If I highlight those numbers, you'll see in the name box to the left of the formula bar that I've chosen 17 rows by one column. What about the sales heading in B1? Well, the count function specifically only counts numeric values. It ignores text. This will work perfectly provided we never skip any blank rows in our workbook. Okay, so now that we know how many rows we have, let's start to build the offset function. We want to add up some numbers, so we start with equal sum, and then type offset. I want to start from cell B2, my first sales figure, and then go down a certain number of rows. How many rows do I want to go down? Well, first, I have to figure out how many rows we have today, so that's the count, and then subtract 12. Next, how many columns do I want to go over? Well, I'm starting in the right spot. I don't want to go over any column, so I will put a 0 here. Now I specify what shape of a range I want. I'd like to have 12 rows because I want the last 12 months. So 12 is the height, and for the width, it's one column. After finishing the offset formula, we have to put a closing parentheses to close the sum formula. 78,078. Let's see if that worked. I'll highlight the last 12 values and check down in the status bar, and sure enough, the sum is 78,078. Let's test and see if it works for the next month. Type September 1st, 2008, and put in a sales figure. Excel automatically updated our formula because we now have 18 values, and so Excel was able to start adding in row 8 instead of row 7. Again, this is really obscure, but there are times where you need to build this spreadsheet with an executive dashboard to show you the running 12 months, and the offset function will solve the problem. Let's move on. We'll go to the Convert worksheet. This is one of those 89 functions that used to be in the Analysis Tool Pack that we now have available to us all the time. And while most of those functions are very serious engineering functions that you probably wouldn't ever have a use for, Convert is great around the kitchen or anywhere. Anytime you need to convert from anything to anything else, the Convert function can do it. I have examples here. I can convert 47 feet to meters. 47 feet is 14.3256 meters. 5 pounds, LBM is the abbreviation for pounds, is 2,267 grams, or 2.267962 kilograms. I'm sure that was a test on one of my chemistry exams in high school. If only I would have had Excel and the Analysis Tool Pack, it would have been a piece of cake. Look in row 5. Here I'm converting from nautical miles, NMI is nautical miles, to picas. A pica is 1/72nd of an inch. Now I have no clue why anyone would ever need to do that, but you can do it. This is such a useful function. Let's take a quick look at the function and how it works. The convert function, you have to specify the initial value, so in other words, the 47, and then the units, the abbreviation for units, FT for feet, and case matters, it has to be lowercase, and then finally, the abbreviation that you're trying to switch to, which in this case is in cell F2, that's the abbreviation M. For all of the metric units, you can prefix with K to turn it into kilometers or any of the other metric abbreviations. It is amazing how wide and varied this function is. If you click page down, I've left you a table here of all the different abbreviations that Excel understands. In weight and mass, we can convert from grams to slugs to atomic mass units. In distance, meters, statute miles, nautical miles, angstroms. It converts time. You can convert from years to minutes. Now, as we page down through here, force, energy, power, you'll notice that sometimes an item is in there twice. For example, horsepower in watts at the bottom of the screen. In this case, Excel will accept more than one abbreviation, a capital W or a lowercase w for watts. Paging down, it handles magnetism, it handles temperature, and finally liquid measures. If your recipe calls for 3 tablespoons and all you have is a teaspoon, I can never remember what that conversion is, you can now use the convert function to solve it. Now at home, I pitched the idea that we need to have Excel in our kitchen so that way we can figure out tablespoons to teaspoons, and my wife promptly vetoed the idea. Moving on. There are many other functions that we now have available to us because the Analysis Tool Pack has been added to Excel. Basically, all of 7th grade math is now made obsolete with Excel. If you need to figure out the greatest common denominator of two numbers, it's the GCD function. Need to figure out the least common multiple? The LCM function. If you need to figure out fractions, just enter the decimal, 3.76545, and format the cell using Format Cells. I'll use Control 1. Choose the fraction option, and you can choose whether you want the fraction expressed in a 1-digit, 2-digit, or 3-digit denominator. Turns out that that number is 3 in 545 7/12. Now, my hometown is Akron, Ohio, and Akron, Ohio is one of the last places where we still care about things in 30 seconds. The tire industry still measures tread depth in 30 seconds. Even though there isn't a built-in function for 30 seconds, we can choose Custom and then specify that we want to see the number rounded to the nearest 32nd. There we have 3 and 24 30 seconds. It just boggles my mind how many different functions there are in Excel. If you happen to have bad news to report, here we have a simple income statement, $3,981,000 of revenue last year, almost all of it is expenses, and only $82,000 in profit. If your job is to report this to senior management, there's a function for you. Use the Roman function. Hide column B, give the income statement in Roman numerals, and you'll at least be able to get out of the room before they figure out what's going on. Now, who could possibly use the Roman function? There's two people, Paul Tagliabue to figure out which Super Bowl it is this year, and Steven Spielberg. At the very end of the credits, they always put the year in Roman numerals. Other than that, I'm not sure who could really use the Roman function. I recently finished a large project to write special edition using Excell 2007. This is one of those big monster books. There's 3 books that are the big 1,000-page books that are cradle-to-grave books about Excel. You have to write about every single feature and every single function, including the 350 functions in Excel. Most of the time, those books just tend to repeat whatever's in help. And at the outset, I said it would be really interesting if I could find a household use for every single function. I was doing great. I got through 350 of them, but there were 2 functions that completely defied explanation. The first function is square root of pi equal sqrt_pi, which takes a number, multiplies it by pi, and then takes the square root of that. Well, lots of times in my books, I talk about how to figure out which pizza is the best deal, where you have to take pi r squared, but square root of pi has nothing to do with that. There's no pizza example that square root of pi works for. The other one that completely confused me is this function. Fact double function. Now, if you remember statistics, there was a factorial function. The factorial of 7 is 7 times 6 times 5 times 4 times 3 times 2 times 1. But the double factorial takes every other number. So the double factorial of 9 is 9 times 7 times 5 times 3 times 1. I couldn't think of any reason why I would ever use this. I called my math friends. I mean, these are people that teach math in college. They're math whizzes. No idea. I went out to a search engine on the internet, and I searched for fact double, and the only entry I could find was someone in 1999 writing an Excel book saying, I need to figure out what fact double is used for. Does anyone know? And there was no answer. Well, I know the folks at Microsoft, so I pulled in one of my favorites and said, hey, guys, I'm trying to write this book. Can you go back and search through the archives and see if there was any notes about why you added fact double to Excel? Some customer somewhere must have asked for it. They said, we're on it. A couple days later, they came back and they said, we don't know. We don't have any record. We're not sure why it's there, but with 400 million people using Excel, we sure can't take it out because someone somewhere might be using it. One of my books is available every Tuesday. I send a couple of chapters out for free, and so every Tuesday I get to talk to 15,000 Excel users. The next Tuesday, I kind of put a challenge out there. I said, hey, is anyone using fact double? Is there any good reason for fact double? Well, it took less than 2 hours and I had my answer. I was so impressed. And when you hear what fact double is good for, you'll understand that whoever put this in the product, either at Microsoft or Lotus, 15 or 20 years ago, clearly could see into the future. They knew that here in the 21st century, we would have so many cable channels on our TV that there would be not one but 2 cable channels that do nothing all night other than show Texas Hold'em poker tournaments. And sure enough, the fact double function is the function that you use to figure out the probability that your hand will win over an opponent's. There you have it. Fact double for all you Texas Hold'em fans. So back to my book. I'm trying to write about these 350 functions, and when I got to fact double, my only explanation, and I said this with a straight face in the book, fact double used to calculate Texas Hold'em probabilities. And we moved on. Well, my other gambling example is definitely work-related, and this uses the COMBIN function. The reason that this is important is if your local state lottery gets large enough and the office decides to pool their money together in order to enter a lottery pool, you need to be able to figure out what the odds are. And the combine function will do that. Type equal COMBIN. You need to specify how many numbers there are in your local lottery. Put a comma, and then enter the number of balls that they're going to choose from the pool. So if you happen to live in a state that's looking for 6 numbers out of 40, the odds are 3.83 million to 1. As I copy this formula down, you'll see that the odds increase dramatically. 6 balls out of 47 is 10.7 million to 1. 6 balls out of 51 is 18 million to 1. Now, I always use this as a guide. If the jackpot isn't at least $18 million more than our bet, I don't play. Let's move on. Excel is great at generating random numbers, and a lot of people know about the rand function. Let me choose some cells here, and I'll enter the rand function, equal rand, and you'll see that Excel generates a random number between 0 and 1. Generally, it's hard to take that number and extrapolate it up in order to create random numbers between 1 and 100 or something like that. But now, because the analysis tool pack is made part of Excel, we have the new rand between function. Rand between will give you an integer between two ranges. So if we're looking for random numbers between 60 and 100, Control Enter, very easily without having to do any math or use the integer function, we're able to generate numbers in that range. A couple of years ago, my kids wanted to play Monopoly. We had the board, we had the money, we couldn't find any dice in the house. I don't know if your house is like that, but couldn't find any dice. So Dad pulls out the computer, equal Rand between, 1, 6. There's the first die. There's the second die. Every time we hit the F9 key, it rolls the dice again, and you get a new set of numbers. Excel is great at random numbers. What if you need to create random letters? This is one that I know because I've been a programmer ever since the days of BASIC, and I remember the old ASCII character codes. Turns out that as we type the character A, the computer is really storing that as a character number 65. There's a function called the char function, the char function. And if you ask for character of 65, you'll get a letter A. It runs up through 91. Oh, well, that didn't work. Oh, let's go see what happened. So 65 is A plus 26 letters. 65 plus 26, that's 91, but I need to subtract 1 from it because A is the first letter. So let me try 90. There we go. So character of 65 is A, character of 90 is Z. If I want to create random letters, I ask for equal char and then use rand between 65 and 90. There we go. Every time I hit F9, I get a new letter. Let's move on. I have a couple of regression examples to talk about. A long time ago, I used to work in a forecasting department, and one of the ways that we would forecast is to take a straight line regression. Excel is great at doing straight line regressions, but unfortunately, the formula that you need to use is really difficult. Let's go up and look at cell G2. You'll see that it's the line ST function, stands for straight line, and we just have to specify our sales numbers in C2 to C35. But here's the gotcha. The line ST function doesn't return one number, it returns two numbers. It returns the slope and the y-intercept of a line. I hate to get all mathematical on you, but any line is y equals mx plus b. B is the y-intercept, m is the slope. Here's what you have to do to actually pull this off. You have to select two cells that are side by side. So select G6 to H6. Start to type the formula, equal line ST. Select your sales cells. I'll click in C2 and down and the closing parentheses. But you cannot hit enter here. This is one of those special array formulas. We have to hold down the control key, hold down the shift key, and then hit enter. And Excel gives us the answer. It does not give us the headings, and I always forget, is it slope on the left or slope on the right? It's slope on the left and y-intercept on the right. Now, I hate that Excel tells me that this has to be side by side. What if I really want it to be on top of each other? Take a look at this formula in G12. The line ST function is going to return two cells. I can use the index function, that completely useless function that I talked about previously, and say that I want the first row and first column from the result. Simple enough to get the slope. If I go down for y-intercept, I'll ask for the first row and second column. Straight line regression. That's the easy example, unfortunately. Let's move on and look at the next worksheet. In real life, nothing is ever as simple that there's just one variable causing things. Here we have Sally's ice cream stand. She went through the summer and kept track of how much she sold each day in column C. But she also paid attention to what the temperature was that day and whether or not it was raining. When people decide to buy ice cream, obviously you should sell more on a hot day than a cold, rainy day. Hit page up and you'll see how this works first, and then we'll come back and build it ourselves. While line ST returned two cells that were side by side, in this case, we're going to have a large array that gets returned. It's still the line ST function, but it's going to return 5 rows of values. I happen to have two independent variables today, rain and temperature. It will always return one more column than your number of independent variables. Strangely enough, the y-intercept always ends up in the upper right-hand corner, and then the variables work their way backwards. So temperature is the first variable in column A, so the coefficient associated with temperature will appear to the left of the intercept. Rain is the next variable in column B, so the coefficient for rain will appear to the left of temperature. We also get a whole bunch of statistics, and they come back completely unlabeled, so I've built this diagram here to show you where the important statistics are. R squared is always in the first column of the third row. R squared tells you how well the regression worked. It ranges from 0 to 1. A 1 means it's a perfect model to explain what's going on. A 0 means that it's not a good model at all. In this case, 0.88 means it's pretty good. There's also a whole bunch of other statistics that I have labeled there, and if you actually paid attention in statistics class, you would know what they mean. I, unfortunately, did not. Let's go down and take a look. I've colored in the area in blue so that way you know how large of a range you have to select. Type the line ST function. First, Excel wants to know the sales. So our known sales are in C33 through C37. Hit the F4 key. Type the comma. Next, Excel wants to know the known X's. Those are all your independent variables, and those have to be specified in a single range. Select A33 through B42. Hit the F4 key. The constant function specifies whether the y-intercept always has to be 0. In this case, we don't care, so type a comma. And finally, stats tells us whether or not Excel should give us the r squared and all the other values. I do want those, so type true. Click the closing parentheses and then Control-Shift-Enter, and Excel very quickly does the regression and gives us the results. The beautiful thing about the line ST function is that this regression is live. If we would change the numbers, discover that it wasn't really 56 this day, it was 44, Excel will recalculate the numbers on the fly. This is incredibly powerful. I don't know if you remember back to high school math when we talked about regression. It would take you the whole day to do what Excel can now do in seconds. Let's move on. Hey, let's take a quick look at the rank function. The rank function is great for figuring out who the largest number is. I'll select my cells, equal rank of this particular number within this whole range. Really important that you hit the F4 key for that second argument. Control-Enter to enter that everywhere. And we'll see that Glenda is the number 1 sales rep right now. There's a problem with rank, though, in case you have a tie. Look at Kayla and Kevin in row 10 and 11. They both sold 1310. They have a tie for second place, and no one is ranked 3. I guess technically that's correct. Let me show you my next example. In this case, I'm building a report that's going to be on the company bulletin board every hour to show who our sales leader is. I have the numbers 1, 2, 3 in cells E3 through E5, and then VLOOKUP formulas to go over and find out who's ranked number 1, who's ranked number 2, who's ranked number 3. Well, because we happen to have a tie and no one's ranked number 3, my VLOOKUP formulas don't work. I'm going to hit page down and show you the solution. Let's look over here in the rank function. In addition to doing the rank function, I'm also telling Excel to count the number of cells above me that have the same sales as me. Now, this forces Kevin, because he comes alphabetically after Kayla, to be ranked as 3. And I'm sure he's upset about that, but now my report on the right-hand side works. Let's move on. We've talked about the subtotal function. Subtotal function is great because it allows you to put a grand total at the bottom. But here I got a worksheet from someone else who doesn't know about the subtotal function, and they manually entered the sums all the way down. Here's an old accounting trick that I learned from an old accountant. If you have someone who's added all the subtotals in, you can solve the problem by using the sum function, sum the entire range, including the numbers and the subtotals, and because they're all in there twice, divide by 2. There you have it. You can go through and add them up, but I guarantee it works. Sum and divide by 2. Moving on. Hey, we have some numbers over there in column A, and I'm going to put in a count function, equal count. It says we have 19 numbers. That's right. Now I'm going to go over and copy that to column D, and it says we have only 16 numbers. What's up with that? Well, hey, look, we have a couple of letters there, and the count function won't count letters. Isn't that crazy? If you need to count data that has both letters and numbers, instead of count, you have to use count A. There's the 19. Count is a great function. Just be careful that it won't work when you have both text and numbers. Then you have to use count A.